Hello everyone, welcome to another Mighty Explained video. Today we're going to be talking about the pathways of the basal ganglia. So we have the direct pathway, which stimulates movement, and the indirect pathway, which inhibits movement. So let's go ahead and start with the direct pathway. So we're going to start in the cortex, and the cortex is going to be stimulating the striatum and the substantia nigra pars compacta. So the pars compacta is going to modify the striatum via dopaminergic release and stimulation of the D1 receptor. So the striatum is going to go ahead and inhibit the globus pallidus internus and the substantia nigra pars reticulata via GABA, an inhibitory neurotransmitter. So once these two are inhibited, the thalamus will no longer be inhibited because these two typically want to inhibit the thalamus when they're activated. So once the thalamus is no longer inhibited, then the thalamus is going to be active and able to activate the cortex. And ultimately, that's going to result in movement. So let's go on to the indirect pathway. So the indirect pathway is going to inhibit movement. So we're going to begin again in the cortex over here on the left side, and the cortex will stimulate the striatum and the pars compacta once again. Although in this case, there's a small little difference. The pars compacta will be releasing dopamine to stimulate the D2 receptors instead of the D1 receptors as seen in the direct pathway. So next, the striatum is going to be inhibiting the globus pallidus externus, and when the globus pallidus externus is inhibited, it will no longer be inhibiting the subthalamic nucleus. So at this point, the subthalamic nucleus will be active and able to activate the globus pallidus internus. And recall, as I stated before, over here in the direct pathway, when the globus pallidus internus is active, it likes to inhibit the thalamus. So the GPI will be active now, inhibiting the thalamus, and the thalamus will no longer be able to activate the cortex, and that will result in no more movement. So I know that this concept can be a little bit difficult to grasp at first. There's a lot of arrows and a lot of moving pieces, but over here on the bottom, I've constructed a little bit of a summary slide, if this is the way that you like to learn. So I'll just go through it real quick just so that you can kind of visualize where everything is and what everything acts on. So beginning with the direct pathway, we begin in the cortex, as I stated, and the cortex acts on the substantia nigra pars compacta and the striatum, and then you can see the D1 receptors and the dopaminergic output from the pars compacta to the striatum, and the striatum acts on both the substantia nigra pars reticulata and the globus pallidus internus, which both act on the thalamus, and the thalamus goes all the way back around to the beginning to act on the cortex. So next we will look through the indirect pathway. So like before, we are beginning in the cortex. The cortex acts on the substantia nigra pars compacta and the striatum, and you can see the D2 modification of the striatum over here from the pars compacta. Next, you'll have the striatum acting on the globus pallidus externus, which will be no longer inhibiting the subthalamic nucleus. And from the subthalamic nucleus, you act on the globus pallidus internus, activating it in order to have the GPI inhibiting the thalamus, and the thalamus circles around to the cortex. But don't let this figure or this display confuse you. In this case, the GPI is active, so the thalamus is being inhibited. So you're not getting this connection from the thalamus to the cortex. I only drew it this way just so that you can get a nice little visualization of the relationships of the structures that we talk about in the basal ganglia. So that's all I have for you guys today. I hope this video helps. Make sure to like, subscribe, and comment any questions or concerns that you have below.